Okay, so let's talk about this last one. This one's going to take a little bit more time because this is a skill you're going to use for the rest of the year. So I will also talk about this in class, problem solving in chemistry. So what is a general approach to solving a problem? Well, anytime we want to solve a problem, we have to develop a plan and then implement that plan. And in fact, every type of problem I ask you to do, I will give you the plan that you should use to solve that problem with, and then it's your job to implement that plan. So, what are the steps for solving a numeric problem? Most word problems in chemistry are math relates, and because we have measurement, and which is an important part of chemistry, these techniques used in this course to solve numeric problems are conveniently organized into a three-step problem-solving approach. And this is a general approach, however, I will give you specifics for each and every problem type. First, you need to analyze whatever it is you're given. In that case, I ask you to write a data table. Second, you need to calculate something. And eventually, you have to evaluate whether that question or that answer makes sense, if it's reasonable. That's probably the hardest step. So, first, we determine where you're starting from, identifying what is known or given, and where you want to go, or the unknown. What do you want to find? If you expect the answer to be a number, you need to determine what units you want for that answer, because that will often help you figure out how to set up the problem. And then you're going to make a plan for using what you know to get to what you don't know, or to get from the given to the find. So after you have it all set up, then you're going to get out your calculator and you will use the calculator to do your calculations. Sometimes you will have to rearrange that equation, and I am going to be adamant that you rearrange the equation before you try and solve for the unknown. I do not want you putting numbers in, calculating things, and then rearranging. That's not how it's going to work. After you calculate your answer, you need to make sure that answer seems reasonable. Does it make sense? Did you copy the data correctly? So you want to go back and just check your numbers, because that's a common error. And lastly, you make sure that your units are correct and you have the correct number of significant figures. And we'll talk about that in the next unit. So here's an example. I'm not really going to go through it. You can go through it. It's also in your book. So they list what they know, how many blocks they have to travel, how much time it takes to go a mile, and how many miles are in a block. What they want to find out is how long will the trip take. And so now they're going to set it up. They need to go 8 blocks, and there's 10 blocks in a mile. I would not do this as separate calculations like they've done here. But once you know that you need to go 8/10 of a mile, and 1 mile takes 20 minutes and 16 minutes, and that sounds reasonable. And always make sure that your units cancel. I'm going to show you how to do this all in one calculation so that you don't have possibilities of making careless errors. So this one is about the same. He has 176 quarters. What is the value of the corns in his jar? Well, he has 176 quarters. There's 4 quarters and $1, so he has $44. So you need to know the keys for this unit as well, or this section. Effective problem solving always involves developing a plan and then implementing this plan. The steps for solving a numeric word problem are analyze, calculate, and evaluate. The steps for solving a non-numeric problem are to analyze and solve. I cut that out because I figure you know that. And that's the end. Thanks.